Assalamualaikum and good day. My name is Muhamarrazif Kamrussaman. Number battery is E24A3310, and this is my proposal research title: Integrated Geoelectrical Mapping and Subsurface Characterization of Geothermal Conduits in the Pedas Hot Spring Periphery. So before we go to the meat of the proposal, let's take a look at the next page of this e-portfolio that I made using Google Sites. First off, the page of the homes is about author, about me, the one that wrote this proposal. Mostly about my university informations, my name, my brief history. I was born and raised in Seremban, Negeri Sembilan, and my interests such as in geology and ecology. Okay, next we go to the introduction part of the proposal, the real meat of these presentations. Oh, the picture of Bedas. So when it comes to geothermal, Malaysia really came up. Usually it's Japan or Iceland, where volcanic activity ran rampant. In Malaysia, though, the volcanic activity are mostly non-volcanic in origins, linked to the tectonic framework of the main range granite province, and it's mostly because of the degradation or decay of isotopes, elements such as uranium, thorium, and potassium that produce radiogenic heats. So geologically, in Pedas, the site is situated on massive batholith consisting of primarily Triassic age photopatic biotech granites. Alright, let's see. The problem statement is mostly about how that we don't really have a subsurface mapping of the geothermal conduits in Pedas. Even though it's a very important geotourism spot and future engineering and development project can effect these conduits that feed into the hot spring if the correct geothermal mapping cannot be used as a reference. Alright, let's see. The three main objective of this research proposal is to map the subsurface stratigraphy and delineate the special layer of high conductivity zone associated with thermal fluids using 2D electrical resistivity imaging (ERI) to isolate active hydrodynamic and hydrothermal outwelling zone from stagnant clay overburdens by measuring localized streaming potential via self-potential method (SP), and finally to correlate or to synthesize the joint geological anomalies (ERI and SP) with regional structural lineaments to construct an authentic data-driven subsurface geothermal conduits model. Alright, the scope for the study is mostly around the periphery of the Pedas Hot Spring, wet well geotourism spot there. And in this research we use Werner's Schellenberger array configuration to balance vertical sensitivity with lateral resolution, and coupled with the SP self-potential profiling using fixed base configuration. Alright, then for the significance of study, mostly because of the how important Pedas is in Negeri Sembilan geotourism. The study hopefully help to be a reference for future development in the region, so that the geothermal conduit are not disturbed and then can't feed the hot spring in there. Alright, this is the map of this is from Google Map, the map of the Pedas periphery, Pedas region. This is the Google Earth view. As we can see, it's mostly still greenery. It's mostly agriculture buffer zones. This here the map of Rembau with Pedas in the northwest. Study area, the coordinates is 2 degree and 37 minutes north to the north, and 102 degree and 3 minutes to the east. It's located in Rembau, constituency of Negeri Sembilan, like I said earlier. So because there's a water park itself, there's a cultural noise that need to be minimized later on. Okay, now let's see literature reviews. Some of the literature reviews that I did is mostly about the geothermal system in the Peninsula Malaysia, especially on the main range granites. Secondly, the second review I did is about hydrothermal circulation and the structural control of hydrothermal conduits. This is a third review, which is inversion or electrical resistive imaging methods in geothermal exploration. this figure actually is one or what you call expected results at least. This is from a study in Mantin Negeri Sembilan, quite close to Pedas, not too far. And then also critical evaluation of the electrode for the ERI, the configuration. In this research, we ended up using Werner arrays, Werner Schlumberger hybrid arrays, because it offers reliable operational compromise by providing both superior sensitivity to vertical structural change, while also maintain quite a strong signal and stability, also very good depth coverage. This is self-potential methods. We reviewed the principle of self-potential methods here. Also one of the results supposedly, and then we also did a review. So I did a review on regulative and cultural noise around the area, especially in the buffer agricultural zones, and some pipings and the park itself, metals, electrical interference, something like that. This is our final, what we say, the synthesized version, the synthesized final map of the both of our results supposedly. Again, this is from Mantin Negeri Sembilan, and we also did research on the past research, which one this mentioned in Mantin Negeri Sembilan, which is the closest one to Pedas, and the knowledge gap is mostly about how there is no subsurface map of Pedas geothermal conduits. Let's move on to materials and methodology. Materials here, the main one is ABAM thermometer, LS multi-channel geophysical logging system, and GPS by Garmin. Also, you need the electrodes, and a saline and ACL solution to reduce ground electrode contact resistance. For data processing software, we have Process for ARI data filtration, the Studio A, Inverse for smoothness constraint to the CCTV emission model, Microsoft Excel for self potential correction, and ArcGIS or QGIS depend on situation for special demand overlay and mapping. Research design is mostly non-invasive. Data acquisition, ERI configuration itulah 61 electrode system with hybrid Werner Schlumberger configuration. It's mostly capture resistivity. SP capture self potential or self potentials, and SP deployed along the same local coordinate as the ERI line. This is the Werner Schlumberger diagrams, the configuration. So the procedure is first in the infill data acquisition. We capture data at the field. We map the coordinates. For ERI using stainless steel, 300-meter lines, and for the self potential also same line. Converted commercial data, ERI data we draw, extracted to process to, and then we inverse using REST2DA inverse. For the SP, we use Excel to correct the drift, and finally mapping using ArcGIS or QGIS. After that, we can analyze the subsurface characteristic of Pedas periphery. This is the procedure. This is the procedure flow chart, and then this is the overall research flow chart. We can see here we start with the literature review, then we do site study. After that, you can see infill grid layout. So we lay down layout for the study, and then it branch into two, which is the active 2D RI survey and passive SP survey, which run both at the same time, but with different data. After that, we interpret the both data. We join the data into a GIS program to create a subsurface maps, and finally, we can write result discussion and conclusion before we end. Here's the Gantt chart for the whole project, expected to start on March 2026 and end in February 2027. So this is the milestones for it. Mostly the important ones are project initiation, framework completion, complete processing and modeling, structural integration, synthesis, and finally final evaluation. The dates are on screens. Research budget. Before we end, this is the research budget for this proposal study. Most of them are provided by university or self-owned. But some of the stuff are self-funded, such as field nourishment, field transportation, field consumable, and stationery or printing. Also contingency plan and others fee that is needed, which bring up to the grand total of 2,150 ringgits. And finally, this is the reference or some that I use, some of the journal and research that I use for literature reviews and stuff like that. All right. I think again, like I said, as for us for the expected result, it's mostly look like this, and finally like this. Though this one in Mantin Negeri Sembilan, it's quite close, so it can still it's still in the main granite range, so it can still be used as an anchor for the whole project. All right, all right. That's all from me. Thank you very much.